Pandora, that magical planet with floating mountains and crazy glowing jungle you've seen in Avatar, could be real. Scientists, thanks to the mighty James Webb Space Telescope, might have found a planet in almost the exact spot where Pandora is set in the movie. It's the same star system, Alpha Centauri, our closest neighbor, just 4 light-years away. The planet they spotted is called S1 for now. Sounds like a phone model, but this thing is a gas giant like Jupiter or Saturn, just a little lighter. You couldn't land on it, it's just a giant ball of gas. Temperatures there are around 40 to 50 degrees below 0 Fahrenheit. But here's the plot twist. Gas giants often come with moons. Jupiter's got 95, Saturn's got more than 140. And some of those moons are fascinating places for life. Europa with its underground ocean, Titan with lakes of methane. Now, S1 is a gas giant like Jupiter and Saturn, but sitting in the habitable zone of a sun-like star. That means warmth, liquid water, chemistry. If S1 has moons, and at least one is Mars-sized, then we've got the closest possible spot where extraterrestrial life might actually exist. The James Webb Telescope had a hard time spotting S1. Alpha Centauri A, the star it orbits, is so bright that it was like trying to look for a firefly sitting next to a car's headlights. The telescope had to put on special cosmic sunglasses called a coronagraph to block the star's glare. And for a moment in 2024, it worked. The scientists saw an object over 10,000 times fainter than Alpha Centauri A, but twice as far from it as our Earth is from the Sun. But when they went back in early 2025 to check again, poof, gone. Some people even thought it was never there, but the data suggests it's real and it's probably just swung around in its orbit, hiding behind the light. Astronomers think we'll be able to see it again around 2026 or 2027, when they test a new, super advanced telescope. And then we'll probably get the answer if it's good for life or not. But even if it's so, it doesn't mean we should all pack our bags and move to Pandora. Even if S1 has a habitable moon, it's still 4 light-years away, and that's about 25 trillion miles. If you hopped on the fastest rocket humans have ever built, you'd still be traveling for tens of thousands of years. So yeah, not exactly a weekend trip, but in terms of science, this is huge. It gives us a target, a place to point our telescopes, a system where we can dream of sending probes someday. And it's pretty wild that the first serious Pandora candidate is in the exact same neighborhood James Cameron picked for his movie. S1 isn't the only new planet blowing the minds of scientists. In June 2025, the James Webb Telescope spotted TWA-7b. It's a baby giant planet, orbiting a star just 110 light-years away. The star it orbits is only 6 million years old. That's nothing in space terms. Earth is 4.5 billion years old. This star still wears a dusty debris disk around it, the leftover construction materials from planet building. Since the 1990s, astronomers have tracked down about 5,900 exoplanets. They found almost all of them indirectly, through the slight dimming of a star's light when a planet passes in front of it. It's called the transit method. So they directly photographed less than 2% of all those thousands of worlds, and TWA-7b is one of them. It's actually the lightest planet ever directly imaged, 10 times less massive than the last record holder. That's insanely small for something Webb could spot, and it shows just how ridiculously sensitive and powerful Webb's instruments really are. Then there's this star system, called L98-59. It's only 35 light-years away, still close, just a little farther than Alpha Centauri. Scientists already knew it had a few small planets, but in 2025, astronomers found a 5th one. It's about 3 times as heavy as our Earth, about 1.4 Earth radii, and completes an orbit in 28 Earth days. It sits right in the habitable zone. That means it could have liquid water on its surface, if it's rocky and has an atmosphere. This system is basically a mini solar system with several planets lined up like ducks in a row. The star itself is a red dwarf, so it's cooler than our Sun. But that just means the habitable zone is tucked in closer. If we ever detect an atmosphere around L98-59F, it could reveal gases like oxygen or methane, which are signs of life. Scientists are already itching to point Webb at this planet and try to sniff its air. This could be one of the best candidates for finding another Earth-like world. And speaking of Earth-like, meet another candidate for life. This exoplanet is about 20 light-years away, orbiting a Sun-like star. It's what scientists call a super-Earth. That means it's rocky like Earth, but bigger, about 6 times the mass. With stronger gravity, it might hold on to a thicker atmosphere than we do, which could mean more stable climates. And it's in the habitable zone too. But this exoplanet doesn't just cruise around its star in a neat little circle like Earth does. Its orbit is eccentric, which basically means it swings closer and farther from its star as it loops around. That's a big deal, because it actually drifts in and out of the habitable zone, the Goldilocks zone where liquid water could exist. At some point, any water there might freeze solid, and at other times it could melt into oceans, depending on where the planet is in its journey. This weird setup gives scientists a kind of playground for testing and tweaking their habitability models. And since it's so close in cosmic terms, its light is stronger and easier for our telescopes to pick up. So it's a dream target for the next-gen telescopes. And if we ever develop interstellar probes like little robotic scouts that can zip along at a fraction of light speed, HD 20794D would definitely be one of the first stops. Of course, not every planet out there is cozy or habitable. TOI 2431b is about 1.5 times Earth's radius, 6 times heavier, and has a crazy density. It hugs its star so tightly that it completes an orbit in just 5.4 hours. That's right, an entire year on this planet is shorter than your workday. The distance to its star is way closer than Mercury is to the Sun. That's why its surface is cooked at around 2000 K, and that's hot enough to melt rock. Because of its extreme orbit, scientists labeled it an ultra-short period, USP, Earth-sized exoplanet, one of the shortest period worlds we've ever found. The planet is also likely tidally squished, with its shortest axis being about 9% shorter than its longest, stretched like Play-Doh. Plus, scientists calculated how long before its orbit starts collapsing, and it's only 31 million years. That's shorter than any other known USP planet. In cosmic terms, it's like a firework going off. Blink, and it's gone. As for the host star, TOI 2431 is about 2/3 the mass and size of the Sun, roughly 2 billion years old, and cooler and dimmer than our Sun. Obviously, TOI 2431b isn't a place for life. It's way too hot, way too extreme. But astronomers think this exoplanet is a prime target for the James Webb Space Telescope. It could study the way light changes as the planet orbits to figure out whether it has an atmosphere and what its molten surface is really made of. Every planet humans find, whether it's a potential home or a doomed fireball, tells us something about what's possible. The discovery of S1 near Alpha Centauri feels extra special because it's right on our doorstep. Of course, we're still waiting for confirmation, but when or if we get it, it'll change the whole game.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1. And recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called Trappist 1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. Trappist 1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades, we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100-gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri B. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star, which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri B. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri B isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri B makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
For what seems like ages, scientists have been hunting for another Earth, perhaps to find cosmic neighbors, or maybe just to have a backup planet for potential relocation in case we can't turn this one around. Now, thanks to the James Webb Space Telescope, they might finally have a strong candidate. It's called TRAPPIST-1e and is located 40 light-years away. 1e orbits a small star called TRAPPIST-1. It's an intriguing system that has 7 Earth-sized planets, all of which are nicknamed with letters from B to H. While 40 light-years won't be reachable anytime soon, that's still close. Well, in space terms at least. Our galaxy, the Milky Way, is about 100,000 light-years across. So compared to that, 40 is like a walk down the driveway. Or at least will be if our spaceships achieve a speed close to the speed of light, just like in the movies. Remember, a light year isn't a measure for time. It's how far light can travel in 1 year, which is close to 6 trillion miles, which is a lot of zeros. So multiply that by 40 and you get the location of TRAPPIST-1. So bring a big lunch. T1 is a red dwarf, a type of star that's basically like a dimmer and smaller version of our Sun. It's only a bit bigger than Jupiter. Among this family, 1e sits in the star's sweet spot, the so-called Goldilocks zone. Not too hot, not too cold, at a distance where liquid water could exist on a planet's surface if it has the right atmosphere. Perfectly habitable, at least for creatures resembling Earth's residents. However, it's not just located at just the right distance, which is a huge plus. 1e also happens to be a rocky planet. Its size and mass are close to Earth's, which suggests it has a similar density and structure, as well as similar gravity, meaning no cool jumps like on the Moon. Now, Webb has picked up hints that there could be an atmosphere. The planet might be wrapped in gases like nitrogen, carbon dioxide, and methane. We have such a mix over here, too. Earth's air is built from the same elements. Atmosphere matters. Mars lost most of it, Venus has too much, and Earth got it just right. That's why we have cozy weather and oceans. If 1E really does have something similar, it could mean clouds, rain, and maybe even seas. The stuff that would make Earthlings feel at home. However, here is where it gets interesting. We mentioned that 1E is a red dwarf star, and that makes it dim, hundreds of times dimmer than the Sun. If you were standing on 1E, the star would look way bigger in the sky than our Sun does here. But it would glow red and dull. It would be like living under a never-ending sunset. You might think, sweet, it would be romantic, until it gets old. I mean cold. It has to be freezing, right? After all, how can such a faint star provide enough heat for life the way our Sun does? Well, funny enough, you won't need super winter-resistant jackets. The trick is distance. TRAPPIST-1e orbits extremely close to its star, just about 3% of Earth's distance from the Sun. If the planet were sitting where Earth is, it would be a ball of ice. But being so close also means that its year is only around 146 hours. That means it takes 6 Earth days for 1E to resolve around T1. Celebrating birthdays every 6 days sounds like a great deal, huh? That's a lot of cake. But wait, does that mean that each season would last about 36 hours? No, because the planet is almost certainly tidally locked. That means one side bakes in endless daylight and the other side is stuck in eternal night. Not exactly Earth 2.0. Without an atmosphere, you'd get a scorched wasteland on one side and an ice cube on the other. But with an atmosphere, the air can spread the heat around, smoothing things out. In theory, the comfiest spot might actually be the twilight strip between day and night, the so-called Terminator line. Again, a permanent sunrise or sunset. Instagrammers would love it. Red dwarfs are actually the most common stars in our galaxy, making up about 70% of all the stars we know about. And they live practically forever. Our Sun is projected to last 10 billion years. Red dwarfs could go on for trillions. That's more than enough time for life to develop. However, the short straw is that red dwarfs are kind of feisty. They erupt with powerful flares that blast out intense radiation. So, for planets orbiting so close, those flares can strip away atmospheres and sterilize the surface. It's like having a dream house with a beautiful view near a dynamite factory. Oops. That's what makes TRAPPIST-1e so exciting. If it does have an atmosphere, it would mean it somehow resisted billions of years of flare activity. And it might not be the only one. There could be plenty of exoplanets like this out there. Now, you may be wondering how scientists could possibly know what's going on with a small planet that's so far away. Well, they study light using a technique called transit spectroscopy. When TRAPPIST-1e passes in front of its star, the light filters through its edges, revealing clues about its air. Repeat enough times, and we start to see what it's really like. That's one of the most important features of the James Webb Telescope. It doesn't just snap pretty pictures. It dissects that light into thousands of slices, each revealing a different clue. It's also great when you remember that E1 is just one of 7 planets that orbit so close. So scientists have a lot to study in that part of the universe. Each transit gives them a little more data, and after enough passes, they can start to rule things out. No thick hydrogen blanket? Check. No Venus-style carbon dioxide swamp? Looking that way. What's left is a planet that might, just might, have something closer to Earth's atmosphere. In other words, nobody's sending probes to TRAPPIST-1e anytime soon. But with telescopes like Webb, we can already peek at its air from across the galaxy. If you follow space-related news, you are already aware that 1E isn't the first so-called Earth-like planet that reached headlines. Astronomers have been teasing us with candidates for years, and each one comes with a but. As in, however, not your butt. For example, Kepler 186f. Back in 2014, it was the first Earth-sized planet spotted in the habitable zone of its star. People were really excited. NASA even made a sci-fi-style travel poster. The catch? Oh well, just one minor thing. The fact that it's about 500 light-years away. Even if we build a spaceship that could cruise at a tenth of light speed, which we can't, it would still be a 5,000-year-long trip. Then there's Proxima Centauri B. This one is close, just 4.2 light-years away, orbiting the nearest star to our Sun. On paper, it's a dream. However, its star is even moodier than T1. Proxima exhales massive radiation flares regularly, which makes everything unpredictable and unstable. And then we have K2-18b. The James Webb Telescope actually spotted methane and carbon dioxide in its atmosphere, gases which might hint at biological activity. Sounds great, except the planet is more like a mini Neptune, probably wrapped in thick gas layers and unlikely to have a solid surface to stand on. The bottom line? When compared to all these, TRAPPIST-1e looks like the most promising one. Close enough to study, rocky enough to stand on, and sitting in a sweet spot where liquid water could exist if conditions line up. Of course, we still need more data. 1e could turn out to be a barren rock. But the bigger story is that we're getting better at this. A few decades ago, we didn't know if other solar systems even existed. Now, we've found over 6,000 exoplanets, with more getting added almost every week. Odds are, plenty of them will be rocky, Earth-sized, and orbiting in the Goldilocks zone. Maybe we can't go there, but they could mean the discovery of extraterrestrial life. That's the exciting part. Every time Webb or the next generation of telescopes take a look, we inch closer to answering the big question: are we alone, or is the universe full of neighbors? Hey, get your dog off my lawn. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds.
warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. A vast galactic mystery has recently baffled astronomers. They've noticed that all but one of Andromeda's 37 satellite galaxies point toward the Milky Way. It's so extraordinary that it challenges current cosmology and might provide the answer to the dark matter question. So it happened like this. One day, scientists looked at those other satellite galaxies that go around Andromeda and spotted a really weird alignment. Now, we should keep in mind that Andromeda is kind of like our Milky Way's neighbor. It's huge, about twice as wide as the Milky Way, stretching 200,000 light-years across. It also has way more stars, around 1 trillion, compared to our galaxy's mere 250 to 400 billion. Just like our galaxy, it has a bunch of tiny galaxies called dwarf galaxies spinning around it. There are 37 of them. The strange thing is, almost all of those little galaxies are on the same side of Andromeda. And it's getting even creepier, because it's the side that faces the Milky Way. Only one galaxy is hanging out on the other side. Imagine tossing a bunch of marbles around a tree with nearly every single marble landing on just one side. That's weird, isn't it? Scientists say that this discovery doesn't match what they expected at all. Their usual space models show that stuff like this should be spread out more evenly. But this isn't even close to even. It's so lopsided that they can't really explain it yet. Those models follow the main space theory we use today, called the lambda cold dark matter model. According to this theory, the little galaxies should be spread around Andromeda pretty evenly, maybe just a bit lopsided. But in real life, their distribution is way more uneven than the model said it should be. The scientists have run tons of simulations, and only about 0.03% of them ended up close to what we actually see. And still, none of them matched the real thing exactly. So, does it show the Lambda CDM model has flaws? That would be a big deal, because we normally use this model to explain how the universe works. If the real sky doesn't match what our model says, especially in a place as close and well known as Andromeda, it might mean that we're missing something big. Another strange thing, many of Andromeda's satellites seem to lie in a flat plane instead of being randomly distributed in all directions. This kind of flattened structure has been seen in other big galaxies too, including our own, but it's still not well understood. Maybe the satellite disk is connected to the weird cosmic asymmetry, but no one really knows how. In any case, the fact that all the tiny galaxies on Andromeda's side line up almost perfectly in the direction of the Milky Way is super weird. It makes you wonder, could our galaxy be pulling or affecting them? But the catch is that nothing like this is happening to the Milky Way's own satellites. Plus, the gravity between our two galaxies doesn't seem strong enough to do that kind of pulling. The answer might lie in one of the most mysterious things the universe has to offer: dark matter. Let's start from the very beginning. We'll go all the way back to the early universe, just after the Big Bang. Now, back then, I wasn't around then, but I'll tell you anyways. Matter in the universe was spread out pretty evenly, but not perfectly even. In a few spots, there were just slightly higher amounts of matter than in others, tiny clumps. Those little differences were important, because gravity could latch onto them. Over time, those denser regions started pulling in more material,
slowly growing into the first structures in the universe. Astronomers believe that dwarf galaxies were the earliest and smallest building blocks of galaxy formation. Think of them like Lego bricks, tiny pieces that were later pulled together by gravity to build larger galaxies over billions of years. Now, when we talk about matter, we mean two different things: normal matter, the kind we can see and touch, including atoms, gas, stars, planets, and everything around us, and dark matter, the invisible kind. It doesn't give off any light, doesn't absorb it, and doesn't interact with normal matter in the usual ways. The only reason we know it exists is because of its gravitational pull. There's also a lot more of it than normal matter. Scientists think that roughly 85% of all matter in the universe is dark matter. At the same time, we've never directly detected a dark matter particle. But we know dark matter is there because it bends light, it holds galaxies together, they spin too fast to stay intact otherwise, and it shapes the structure of the universe, allowing us to map its influence on larger scales. While normal matter can clump together, crash, heat up, cool down, and eventually form stars and galaxies, dark matter can't do any of that. It doesn't bump into itself or radiate heat, but it can still form big, invisible clumps, which we call dark matter halos. In the early stages of the universe, the halos acted like gravity wells. They pulled in normal matter, which sank into the centers of those halos and formed the first galaxies. So, galaxies like the Milky Way or Andromeda might be sitting inside enormous blobs of dark matter that we just can't see. So, cosmic asymmetry explained? Not yet. Scientists are sure that dwarf galaxies are some of the most dark matter-dominated objects in the universe. In many cases, over 99% of their mass is likely to be dark matter. That means they give us a unique chance to study dark matter without all the messy gas and stars that exist in larger galaxies. Researchers use dwarf galaxies to figure out how dark matter clumps together, or whether there are alternative theories of dark matter, like warm or self-interacting dark matter. At the moment, the main theory is that dark matter behaves like a cold, clumpy, and slow-moving fluid. At the same time, it might not be totally cold. Maybe it has other properties. Maybe it interacts with itself or with normal matter in subtle ways we haven't discovered yet. If that's true, it could help explain why satellite galaxies form in strange patterns, like the ones around Andromeda. In other words, the lambda CDM model might indeed have flaws. According to it, thousands of dwarf galaxies should be orbiting around larger galaxies like the Milky Way and Andromeda. But we only see a few dozen. This is known as the missing satellites problem. There are other puzzles too. For example, lambda CDM predicts that dark matter halos should be the densest at the center, but many dwarf galaxies seem to have cores of their own. Plus, dwarf satellites around galaxies like Andromeda and the Milky Way seem to lie in thin, co-rotating planes, and it's something extremely rare in lambda CDM simulations. And finally, some simulated dark matter halos are so massive that they should form bright dwarf galaxies, but we don't see them. No wonder astronomers are so interested in dwarf galaxies and the explanation of cosmic asymmetry. For that, we need more precise measurements of their motions and structures and simulations that add more realistic physics, like stellar feedback, turbulence, and so on. Plus, we gotta search for new dwarf galaxies in the local group and beyond, using better telescopes and deeper surveys. Now, getting back to Andromeda's weirdly positioned satellites, if the dark matter theory doesn't work out, there's another possibility that involves large-scale interactions between galaxies. It could be an old collision or a near miss that shaped the current distribution of satellites. For example, some scientists think a smaller galaxy, Messier 32, might have collided with Andromeda long ago, stirring things up. Scientists have seen some lopsided shapes in other galaxies before, but none as weird as what's going on around Andromeda. Usually, the little galaxies around big ones spread out pretty evenly or are just a bit off. That makes scientists think Andromeda might be a super special case. They say we need to keep looking, using better telescopes, to crack the Andromeda galaxy mystery. And perhaps, after figuring out the truth, we'll also come closer to solving the dark matter problem. 2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxy by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect. But when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day. or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these 2 Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri B is the closest Earth-mass exoplanet at 4.2 light-years away. So, these 2 new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with 2 instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these 2, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The 2 planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the 2nd most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us.